Okay.
Sir, from the previous equation, I get that the minimum values of z are -3 and 3. And then you told that to change from minimum to maximization. So can you please repeat that once more? Please, sir.
No, I actually considered that there are two problems. One is this. Let me write the problem, then that will be clear to you. One problem, suppose, is this: x minus y is mean z is x minus y, and subject to x plus y greater than or equal to 3,
Yes, sir.
and 2x plus y 2x plus 2y
Greater than equal to 4.
2x plus 2y greater than or equal to 4. This is one
Yes,
problem.
sir.
And x comma y greater than or equal to 0. This is my problem number 1, problem number 2, and my problem number 3 was same problem. Let me write it in its entire form. This is max z, which is x minus y, and subject to the same constraints. It is x plus y greater than or equal to 3, and 2x plus y 2x plus 2y greater than or equal to 4, x comma y greater than or equal to 0, x comma y greater than or equal to 0. These are the two problems. Now I said, if the problem is of minimization type, as you see, I do not have the figure with me right now, but you have the figure with you. Common feasible, look at the common feasible region I obtained for this one. The common feasible region is the region where the green color and red color mingled with each other. And that was
Yes, sir.
bounded by the straight line from below, by the straight line this. I said, since it is a minimization type of problem, so we have to consider we have to minimize, try to we shall have to try to minimize the values of x. What is the lowest point? What are the corner points of that particular straight line which bounds this region? The corner points are 0, 3 and 3, 0. So 0, 3 is one possibility and 3, 0 is one possibility because they are the corner points. And I told you that in linear programming problem, corner points yields the optimal solution. So since the problem was of minimization type, I considered the coordinate of the corner points and I substituted the coordinates. I substituted x equal to 0 and y equal to 3, I got -3. And then I substituted x equal to 3 and y equal to 0, I got +3. And I compared the value -3 and +3 over there. -3 is the minimum of the two, and therefore I said that the minimization type of problem has a solution, unique solution. It is the value is -3, and the value of the variables are x equal to 0 and y equal to 3. But in the second case, the common feasible region remains same, and it is bounded by the straight line x plus y greater than or equal to 3. But now, since there is a change in the objective function, now the objective function has become of maximization type. And since the objective function has become maximization type, we cannot consider the lowest corner point over there, 0, 3 and 3, 0, because lowest corner point will always yield the lowest values. So it is quite obvious that if we keep on increasing the values on the positive direction, then the objective function will keep on increasing. And what are the limits? If you look into your diagram, you will see that the region where the green color and red color mingled with each other, it is bounded from the lower end, but it is unbounded from the upper end. So on upper end, there is no bound at all. So you can increase your y-axis and x-axis. You can keep on increasing your x-axis and y-axis, and you will get many such points lying on that particular portion, which when will be substituted in this particular objective function will yield higher value of the objective function. So this has got a unique solution and this has got unbounded solution.
Okay, sir. Thank you. Mhm.
Any other question? No question. So hopefully, since there are no questions, so probably the students have understood. Uh, have success. Uh, I am successful in transferring the knowledge of graphical method to you in in a suitable way, because there are no questions at all from your end. So I hope that you have understood the graphical method. Okay, so we have time. So let's do, we have some time, 20 minutes. So let's do another problem. Let's try to do another problem and let's see, that will be a kind of practice. Okay, so what shall I select? Um, Let me select a problem like, say, okay, let me ask a question to you. Suppose we have a linear programming problem of this form. Suppose we have max z is equal to 2x plus 3y, 2x plus 3y. This is my max z. And suppose the constraint is say just this, x comma y greater than or equal to 0. This is question number 1. And suppose I have another question for you. This is question number 2, where I am writing min z is equal to, same problem, 2x plus 3y and subject to only one constraint. This is x comma y greater than or equal to 0. What will be the solution for this one and for this one? See, in this problem, there is objective function, non-negativity constraint, but other constraints are not present. They are irrelevant. Constraints come as part the requirement of the problem. The requirement is not there, so constraints are not there. Mathematically, I can consider this particular scenario. You may not agree with me. You may think that, sir, it is not impossible. It's quite impractical. Yeah, okay, no problem. It is impractical. In a linear programming problem, in a practical case, constraints are always present. It's not improbable, but impractical. Okay, I am putting an impractical problem in front of you just to see just to check your technicality. So in the first problem, in this particular problem, what I do, I'll draw the straight lines, x-axis. This is my x-axis, and this is my y-axis. And since there are no constraints and x comma y greater than 0, that means what? That means I have to consider the entire portion lying on the positive quadrant. So entire positive quadrant is my feasible region. The entire positive quadrant is my common feasible region because there are no other constraint. And since this is a maximization type of problem, so answer will be unbounded. If you keep on increasing the values of x and y, then your solution will keep on increasing. For the second phase, I do the same thing. I draw x comma y. And here also, since no other constraints are there, the entire positive quadrant here is your common feasible region. So entire positive quadrant is your common feasible region. But now the problem is of minimization type. So you have to keep this in mind. And therefore, you have to consider the minimum value. What is the lowest value of this region? The lowest value is origin. So here, the answer is unbounded. And here the answer is x equal to 0 and y equal to 0. I'm just checking the technicality. I'm just showing you the technicality of the system. Okay, these two problems are improbable. They are not improbable, but impractical. Okay, so this happens. You have to check whether what sort of objective function is given to you. You have to check what sort of constraints given to you. You have to check what sort of common feasible region is obtained by you. So every aspect of the problem has to be taken into consideration before you put forward your conclusion. One drawback of a graphical method is that, but you can say that, sir, linear programming problem. Now your syllabus says, in your syllabus, it is written that first of all, linear programming problem is there. Then it's formulating maximization and minimization linear programming problems. Graphical solution is there. Then some other methods are there. So you can ask me, sir, why a graphical method can very easily, and we are quite comfortable with the graphical method. So why do we need other method to solve the linear programming problem? The answer is, if the linear programming problem contains two variables, we can very easily draw the two-dimensional graph. But if the linear programming problem contains three variables or more than that, then it will not be possible for us to draw the graphs for more than three variables. Even if it is not possible for us to draw the graph, draw the three-dimensional figures and mark the three-dimensional regions. Software, by using softwares we can do, but manually it is not feasible. Okay, so the thing becomes quite difficult when the number of variables increases, exceeds 2. And therefore, this is the main limitation, the main and the only limitation of graphical method. So graphical method is only applicable easily to the problems with two variable, at most two variable. If the variable is more than 2, we have to switch on to the next variable, next method, which is there. Several other methods are there in the system. We can apply any one of them. Okay, so this is the thing. This is the limitation of the graphical method. You can note it down. This is one of the limitations of the graphical method. And so I have shown you a problem where unique solution exists. I have shown you a problem where infeasible solution exists. I have shown you a problem of redundancy. I've considered a problem where a particular constraint has become redundant. Then I showed you a problem of unbounded solution. I have shown you a problem of minimization type of problem where unique solution exists. So there are possibility. Let me show you another example. Okay, just for the sake of practice, say we have this problem, max z is equal to say x plus 2y. Okay, and suppose it is subjected to two constraints. One constraint is x uh, by -1 plus or y by -1 is equal less than or equal to 1. This is one constraint, say. And suppose another constraint is x by -2 and y by -2 less than or equal to 1. I'm just giving you the problem from my mind. I want to discuss several possibilities with you. If I consider the bookish problems are very tedious and very, what should I say? They are same type of problems are given. Okay, so I cannot discuss several situations which may arise in the technicality of the graphical method. Therefore, I'm giving you the problem from my mind. So according to this problem, let's see what happens. Okay, so I draw the graph quickly, and suppose let me extend the graph like this a bit. Okay, now the intercepts are, okay, what are the intercept? The x-intercept is the point -1. Okay, so let's draw the point -1 over here. And the y-intercept in the first case is -1 also. So let's draw -1 here. Fine. Second, in x-intercept is -2. So let's draw -2. And y-intercept is also -2. So let's draw -2. Okay. Now let us draw the straight lines. So first, my first straight line will be this, and this my second straight line will be that. And if you substitute x equal to 0 and y equal to 0 in this equation, we see that 0 by -1 plus 0 by -1 satisfies this inequation. So origin satisfies this inequation. So the region will be the region bounded by this straight line will be that side which contains this particular origin. So you see one thing, that I'm actually talking about this side of the straight line, bounded by the straight line. And for the second case also, you see this origin satisfies the inequation. So again this side will be considered. Again this portion will be considered. It seems as if this is the common feasible region, and you may say that, sir, this is the common feasible region, it falls in the second quadrant and therefore it has no solution. But hold on, before you give your conclusion, you have to check something. You extend your straight line like this. Suppose this is the straight line. I can extend the straight line on both the sides through to infinity. So I am extending the straight line like this, my straight lines. And if I keep on extending the region, what will I get? If I keep on increasing the region, what will I get? Let me see. So actually I am considering the region bounded by this side. Total part have to consider. This is the part. The parts are also falling on the positive quadrant. You see, these parts are also falling on the positive quadrant. Similarly, if you consider the first straight line, don't consider this portion only. Consider the entire side, entire portion falling on the right hand side. And this will be the entire region. So some parts of the positive quadrant will also creep in into the picture. So you see, ultimately what you are getting this section of the positive quadrant where the blue colored line and the green colored line are getting mingled with one another. And which means that this particular problem has also unbounded solution. Okay, if you keep on
Yes, sir, unbounded.
values of x and y, the value of z will keep on increasing. So this is the thing which these are the things which I wanted to discuss with you in today's class, the graphical method. Now you can select, what you can do is that you go to the exercise 1 of the Hamdi Taha book, and if you have formulated your problem of the exercise, then you can now solve the problems if and only if your problem contains 2 variables. If you find any problem which contains 3 variables, you must avoid, because the 3 variable methodology has not been discussed in today's class. So I hope you do not have any doubt today. If you have a doubt, I am waiting for you. If you do not have any doubt, then I can end my today's session with this. So if you want to ask me anything, then you can. Otherwise, I'm ending that when
One question.
yeah, okay.
Yes. In the diagram, you have shown that in the question it is shown that x comma y it is greater than equals to 0. But you have considered the negative side of the graph also. So it can happen that this equation is given for positive and we can take the negative side of the graph.
No, since it is given, I have considered the negative sides because I had to consider the negative side corresponding to the constraint. But since this negativity, non-negativity restriction was there, that's why I told you that you shouldn't stick to the, if you draw the region, you shouldn't think that this is the common, this should be the common feasible region here, because I am considering the entire portion which is lying on the positive side because of this constraint. This constraint is actually telling me that you shouldn't consider your common feasible region on the negative side. If you extend your if you draw, if you keep on drawing the region bounded by the straight line on the right hand side, on the top side, you will see that if you keep on extending it, you will see that portion of the straight line will fall into the positive quadrant also. There are some portions which of blue color and green color which get mingled with one another here also. Here also. Here also the blue colored line and green colored line have mingled with one another. But I have not considered them just because of this. So therefore, non-negativity restriction always ultimately tells you that if you want to draw the conclusion, think about the positive quadrant. And if you check whether the positive quadrant, is there any common feasible region in the positive quadrant or not. That's why I considered this.
Okay, sir.
Any more question? I wanted to say something, but what was that? Oh, so anyways, I forgot. So this is the thing. These are the thing I wanted to discuss with you today, and this graphical method is softwares will not help you to find the solution. So there are no such kind of methodology softwares which will help you to draw the graphs and see these are actually not feasible. But if there are some algebraic methods to solve linear programming problem, softwares are always available. So graphical method you have to do manually, and you just try to solve the, you can consider the problems which are already formulated over there. That means solved examples containing two variables. You can apply the graphical method and see what happens, what is happening over there. And also you can choose those exercises, those problems in the exercises which contains the two variable problems. And you can also draw the graphs over there to see what is happening. Now, one thing I must tell you, if you do not practice this problem by yourself, then the things will not be clearer. If don't keep the things so that by keeping in mind that you shall study just before the examination, okay, because this is not acceptable as per the rule of WBT. WBT is nowadays considering the continuous, they have gone for the continuous evaluation process. So after certain time, when I shall see that a significant amount of portion has been covered in the class, I shall try to take one test of yours. Okay, the new students, you just inform the new students to see my videos uploaded already in the YouTube so that they can cope up with the ongoing sessions. And today I have understood one thing by taking your class, that when I shared the PDF file with you, I tried to discuss lots of things. I see this was the PDF file which I tried to share with you. Let me share the PDF file once more. This was the PDF file I tried to share with you. When I discussed, I took some trouble to draw the graphs over there. This particular portion of the figure, and there is a mistake. After so many hard work, there was a mistake. I wrote x in place of y and y in place of x, but this particular thing took me 15 to 20 minutes. After 15 to 20 minutes of trouble, I were with some error, I was able to draw this particular figure. I started with this PDF file, and many such problems were actually hovering inside your mind. And I very well know that you faced lots of trouble. If I could finish my class at that, if it was a one period class. If it were a one period class, then I could have stopped my class at this juncture after after the explanation of this PDF file. But once I used the whiteboard, once I drew the calculation by myself, everything becomes clear to you. So you see how beautiful this chalk and talk policy is. Okay, maybe because of some unforeseen events, we are stuck at our home with this online blended online teaching learning process. But I actually am not very much comfortable with this process. Mathematics teachers are not actually comfortable. I actually participated in various sessions where teachers discussed uh, softwares, tools to take classes, online classes. How can I do this thing or that thing? But nobody could properly reply how a person can teach on mathematics beautiful way on online classes. There is no such way. Mathematics class can only be done in whiteboard, and that I believe. And maybe we have shifted to the blended online teaching learning process, but one day will come when we'll get back into the primitive style of teaching, and we'll get into the we'll again go for chalk and talk policy. Hopefully your uh, physical classes will start soon, and I am actually waiting for that. I'm fed up with this online system, and I want to meet you personally so that I can discuss one-to-one in front with you in the classroom, and I can draw the curve and draw the graphs and do the calculations. Uh, this is the better way of teaching, I think. And you may not agree with me. If this were a history class or this were a class like political science, then I could share a screen. I could share a particular page, and I could discuss. I could go on discussing the things and tell you stories like this. But mathematics, if you don't do it by your hand, then mathematics is a kind of language. If you don't try it by yourself, that things will not be clear to you. No lectures. Even if I keep on if I go on like giving you lectures for 5 to 6 hours, things will not be clear. 5-minute practice by hand is far more better than 5 hours teaching by showing PDF files. This is my judgment. I don't know whether you support me or not. So anyways, until unless we get notification.
One last question.
Yes.
Yes, you said what is the limitations of graphical method? Can you say it once again? My net
If
got
the number of
disconnected.
variable is more than 2, then suppose if I give you the variables, 3 variables, then you cannot you don't have to consider you shouldn't consider the 2-dimensional figure. For 3 variables, you have to consider a 3-dimensional figure. So 3-dimensional figure means is quite difficult to draw, and the region will not be like this. Okay, maybe it's kind of region bounded by a house, and you have to show the house. The house contains the region. It becomes very difficult if I consider the 3D. But even if you can do it by some hard work, then if I move on further, like to go to 4 variable problems, okay, then what will you do? How can you draw a 4-dimensional curve? How can you do a 5-dimensional curve? A mathematical problem can have more than two variables. So we shall not be able to deal with those problems by graphical method, and therefore some other methods are there which will be discussed later on. Understood?
Yes, sir.
Okay, so can I conclude my today's session? Is there any question from your end? Then you can ask me. Otherwise, I'm going to conclude my today's session because it is already 5 p.m. Okay, so see you in the next class. Bye for now, and probably you have class now, so bye.